All right, so this is the last of the four sessions, and this is actually the topic that I tried to duck out on and try to find someone else to do, because obviously, like, there's a little bit of I don't say credibility issue, but a little bit. I can quickly get out of my depth, and I'll try not to. I'll try to more or less stay in my lane, so that doesn't happen. If you remember too, when I started like the first session, I had a picture of me with Darwin, right? And I kind of joked and said he had evolved into a rock, right? And the smart evolutionist would have said, well, rocks take way longer than that to actually be formed. And so how could that possibly be? So this is what I want to start with. It's a rock in a canyon. Dominic's already seen this. And we're going to play the little game of how old you think that is, or how long it took to be formed. Either one. You can go for either one. It's like the little game where you guess how many. Do you already know, Connor, because you have a grin on your face like you already know how old that is? So how long did that take to form? So it was like nice, like the classic, like line, the stratified lines, and the, two biologists in the room. What do you think? If you had a guess, just ballpark it. 120 million years. What do you think? Like 50 million years? Oh, well, see, you're cheating though, kind of. And because you know that, like, in the end, I'm going to show you, like, oh, here's how wrong it was, right? Nope, it was not. No, so I'm not cheating. Totally natural. We do actually know how long it took to form this and how old it is in this picture. If that get, like, exactly, we don't have to use. So anyway, we're going to come back to it. Like, but just think about, like, normally, like, if you didn't think I was trying to trick you, you'd look at that and go, I don't know, few million years, maybe. And it's not that tall, right? If you look at the person in the picture down towards the bottom, you see that I mean, relatively speaking, it's not that tall, but it does have really clean sort of layers. And the little, they're called varve, the little lines, essentially, like every 1 to 3 centimeters, like sort of like the rings on a tree. They're like, okay, every 1 to 3 centimeters of sedimentary rock is a year. And you see there's a lot of them, right? And I'll tell you what I actually found out about how old it is when we get to it in a second. All right, but first I want to do this, all right, because this is the other place we started the first night. All right, remember I said one of the things that got me even thinking about this was when I came across this passage, right? And I said very specifically that St. Peter said that scoffers in the end times were going to scoff about something, and they were going to say something, and it was the sign of the end times. And I said it was intimately tied up with evolution, but I kind of left it hanging a little bit, right? And so we're going to talk about this. So he says that the scoffers are going to say, where is the promise of his coming? Okay, so they're scoffing about the Messiah's coming. For ever since the fathers fell asleep, all things have continued as they were from the beginning of creation. They deliberately ignore this fact that by the word of God, heavens existed long ago, and an earth formed out of water, and by means of water, through which the world that then existed was deluged with water and perished. But by the same word, the heavens and earth that now exist have been stored up for fire, being kept until the day of judgment and destruction of ungodly men. All right, so according to St. Peter, the scoffers are going to essentially deny the truth of Noah's flood. All right, and by saying essentially that everything is as it was in the beginning, all of the natural laws about the way the earth and universe, everything works, is the same as it was from the very beginning of creation. Right, and so this has a name. It's called uniformitarianism. Okay, and it's sort of the prevailing scientific theory, although it doesn't hold up. All right, and that's what we're going to talk about tonight. I could have gone 1,000 different ways with this, like when we talk about the science behind evolution being dubious. What I really want us to focus on is what we know to be true, right? And then use it. Remember, we worked really hard to really set up the sort of hierarchy of truths, right? Where, okay, if God reveals something, it's absolutely true. And we as Catholics, this isn't necessarily how we would argue about it. But remember, my goal here was for us, none of us to turn out to be theistic evolutionists, right? Like, pick a side, and stay on that side. And so the point of this, right, is for us to take as a given the reality of Noah's flood being a worldwide flood. Right? And we're going to talk more about that in a second. But let's talk about what uniformitarianism is. All right, so Charles Darwin, in The Origin of Species. Now, we've already talked about this, I think. Evolution, in order to work, requires there to be a lot of time, right? That's it's baked into evolution, right? And so naturally, or it's going to look for a way to make that possible, okay? And so that's where this sort of theory of uniformitarianism is really convenient. All right, so Darwin says this, he says, natural selection can act only by the preservation and accumulation of infinitesimally small inherited modifications, each profitable to the preserved being, okay? And so we already know that about evolution, right? Like really small inherited modifications take a really long time to get from one thing to another. Even if we just set aside what we said about like a really, vague definition of species, it's still the same, right? It just takes a long time, right? And so here's his justification. He says, and as modern geology has almost banished such views as the excavation of a great valley by a single diluvial wave, that's talking about the flood, so will natural selection, if it be a true principle, banish the belief of the continued creation of new organic beings or of any great or sudden modification in their structure, all right? And so he's saying now that modern geology has proven that there was no such thing as Noah's flood, that opens the floodgates for evolution, all right? And so what I want to go at is first to prove from revelation that there was a flood, and then to show how the science also supports the fact that there was a worldwide flood, right? And how everything lines up, okay? And then for us to sort of understand that this evidence is not easy to find all in one place, all right? And so you have to know how to look. And there's, in science, there's what's called the like file drawer, where people come along and they study something, they find something that's totally unexpected. It doesn't toe the company line or the party line, and they just throw it in a file drawer for later because they thought they did something wrong, thought they can't get it published, whatever it is, all right? And there's enough of these sitting around, if you know the right places to look, to show us even scientifically how evolution doesn't work, all right? And that part is sort of a different talk, but if we at least go, okay, for 1,800 years, Christians always believed in Noah's flood and didn't believe in evolution. So where's the burden of proof, right? Where is the burden of proof? The burden of proof on the Catholics to show that they were right, or is there a burden of proof on science to overthrow what was already believed, all right? And it's a little bit of both, obviously. All right, so what is uniformitarianism? All right, so in his book, at least volume 1, the title sort of tells it all. It says he titles it, or the subtitle is Being an Attempt to Explain the Former Changes of the Earth's Surface with Reference to Causes Now in Operation. Or what does he mean by with causes now in operation? All right, so what he's essentially saying is that everything that operates now, things like erosion, frost, weathering, whatever it is, all the natural laws in operation now can explain everything we see, including that rock formation that I showed at the beginning, all right? Which sounds really eerily similar to what St. Peter said people were going to say, all right? So Charles Lyell, in this book where he introduces uniformitarianism, essentially says, okay, all the former changes that you see in the earth are just results of the natural processes we see going on around us right now, all right, and just over a really long period of time. And his point is that we can explain everything without resorting to any kind of catastrophes, right? So the opposite of uniformitarianism is what's called catastrophism. where catastrophes are what really forms the Earth. And for the most part, the rest of the time in the Earth is pretty stable and pretty predictable, right? Except for these catastrophes. All right, and you can see how even this viewpoint has a whole lot of implications for like the whole climate change movement, right? Because if Earth's climate is basically stable and there's catastrophes here and there, then that changes everything as to how we should approach even something like climate change. Yes.
Climate shifts where it says like big freezes and then warm and then come back and then it almost switch back a couple times. And, it seems like even from kind of sign, even from like kind of the science perspective, they would have done pull up there because they say like it's all cycles.
Yeah, even cycles of catastrophes, right, end up being throwing off uniformitarianism, right? Because if I'm looking at, if I'm looking at rocks, right, like the strata of rocks, and I'm assuming each one is a certain amount of time, I'm assuming they were laid down in a certain amount of, like, if something didn't lay a whole bunch of them down all at once, then, but if it did, then all of a sudden my calculator is off, right? My calendar is totally off. My clock doesn't work because what if I've had 30 layers laid down in 10 minutes, right? And I thought that was 30,000 years, right? And so they, in a certain sense, they need uniformitarianism to be true. And so again, we talked about at the beginning, like evolution requiring circular reasoning, right? And that's one of the reasons, okay? And so the billions of years that we say the Earth is really not based on any scientific observation. It's an assumption, right? So they assume that this is true, that there was no flood. They assume that everything is still operating the way it was. And then they just go ahead and prove it because they've already assumed it, right? And we're going to talk more about that. All right, and so let's look at the philosophy of uniformitarianism and Charles Lyell. But the point is that Lyell wasn't necessarily the one to come up with this. James Hutton was the other guy. It was a little bit before him. And those two are sort of the fathers of modern geology. But Darwin needed them, right? Darwin needed them in The Origin of Species because he needed the world to be really old. Yes?
I see this pattern a lot of like almost there with limits. James could say like natural limits to how far these sciences will go, and then they're like, well, maybe there isn't, and now we need all these things because nothing makes sense about it. What is that kind of part of like a push towards rationalism, where there needs to be this like you can't have this because originally you might say, okay, biology eventually has to get its principles from something. Biology can't explain everything because it was never meant to. Like it has to accept nature as coming from something else. It's not its job to explain the origin of nature.
Yeah, so the question, to sort of summarize, is that how do you respond, or at least to the contention that evolution has to be true? And the truth of the matter is that evolution is the best they got, right? Because they've already a priori moved any supernatural explanation out of the way. So if we start with everything has to be some natural process, some naturalistic process, evolution is the best that we got, even if the data doesn't support it, right? So all they do in essence is take the sort of the habit of putting God in the gaps and replace it with evolution in the gaps. It's no different, right? It just changes what you use, right? It's definitely like it's a movement towards atheism, right? It starts with the heavy deism, and the heavy deistic sort of spirit, and then you eventually go from deism to either atheism or some kind of pantheism, which really evolution evolutionary beliefs are a little bit of both, right? Because it's really the God of evolution is natural selection, right? Or survival of the fittest, whatever you want to call it. And that's just pantheism. That's all that is, right? And so it will always go back to some sort of religion because we're religious creatures and that's the way it goes. All right, so let's look at least the sort of the three tenets or the three chords of Lyell's philosophy. Okay, and he lays this out in his book. Or he says first, okay, the biblical account of Earth history has to be thrown out. All right, it's irrational. It's whatever you want to call it, supernatural. We need a natural explanation. All right, and so despite the fact, and we won't even talk about this very much tonight, despite the fact that all over the world, cultures had a story of a great flood, right? Passed on from time to time to time, right? Details were sketchy, but nevertheless, as true history, it has to be thrown out. And especially because of if the biblical account is true, what comes with it, okay? And then the habit of believing that all geological features can be interpreted in terms of slow and gradual processes, no matter how unlikely or difficult that may seem. Right? And so that the mechanism always has to be some slow and gradual process. And we hear this over and over and over and over. And then finally, a heavy emphasis on geological features that seem to demand long periods of time to form. Right? And we'll talk about how carbon-14 dating at the end is really a young Earth science, and it points almost directly towards a young Earth. All right, so let's sort of dive into this a little bit, and we'll start with what we believe about the flood. All right, so our Lord talks about the flood. All right, so he's talking about the end of the world, and he says, okay, heaven and earth shall pass away, but my words shall not pass. But of that day and hour no one knows, not the angels of heaven, but the Father alone. As in the days of Noah, so shall also be the coming of the Son of Man be. What happens at the coming of Christ? The destruction of the world, right? And so if we go back to that 2 Peter that I started with, he says, but by the same word, the heavens and earth that now exist have been stored up for fire. That an earth formed out of water and by means of water, through which the world that then existed was deluged with water and perished. All right, so at the flood, something happened to the world that changed it fundamentally forever. All right, that's one of our data points. All right, that's one of our data points. All right, and this is why some of the scientific investigations that skip that, right, that skip that there's this definitive point in history where all of the scientific laws were different than we think they were. All right, the atmosphere of the earth was different. The highest mountain was 5,000 feet, right? That's in scripture, right? All of those things, all right? So how did we get from there to there, all right? And again, so remember, we're taking this from the Catholic point of view of what the givens are, and then can we look at the science to support it? All right, so so one of the ways in which, trying to find a charitable way to describe people who I'll call them accommodationists, who are trying to somehow take the scientific account, make it fit with the biblical account. What they'll normally say is that it wasn't really a global flood. It was just a local event, all right? And so in doing that, they could say, okay, well, you know, Noah had this, there really was a flood, but it really didn't go over the whole world, all right? And we're going to show why that's, first of all, not theologically tenable, but not scientifically possible either, based on what we know. All right. First of all, the church fathers are unanimous, right? And I have a quote from Augustine here on a literal interpretation of Noah's flood, of the flood. All right, as certainly a symbol, because God writes with symbols, like we talked about. But there was a literal global flood, the entire world. All right. And of course, just simple common sense question: if it's a local flood, why does Noah have to take all the animals? Right. Why spend decades building a boat when you could just run to higher ground? You know, and why does God promise never to repeat the global flood again? Because there certainly have been local floods since. All right, and so those are sort of 3 data points to go. Wait a second, this is definitely a global event. All right, so what can we then glean about what actually happened? All right, so Genesis chapter 7. Did you have a question, Connor? Genesis chapter 7 gives us a lot of details. All right. In the 600th year of the life of Noah, in the second month, the 17th day of the month, all the fountains of the great deep were broken up and the floodgates of heaven were opened. All right, so first fact, right, that we get from this. Water is coming from below and from above. All right, so the fountains of the deep are opened. All right, so something tectonically happens so that water from below comes up, right? Not necessarily we're saying that the water's in the earth, but we could also say, okay, something tectonically happened that caused the superheating at the base of the ocean, and water literally is shot up into the air, just straight up, and continually does it. All right, which again, we're going to show an example in recent history of something very similar to this happening. All right. All right, so that's the first thing. So it's not just a flood like rain and just raining incessantly. All right, there's a lot of other things going on. All right, because if the fountain of the deep is broken up, that means that the earth itself, the face of it is changing. All right, and the flood gates are open, and the rain fell upon the earth 40 days and 40 nights. And the flood was 40 days upon the earth, and the waters increased and lifted up the ark on high from the earth. For they overflowed exceedingly and filled all on the face of the earth. And the ark was carried upon the waters. And the waters prevailed beyond measure upon the earth, or prevailed beyond measure, stayed on the earth, and all the high mountains under the whole heaven were covered. So the mountains at the time were covered, all right, wherever they were. All right, and so how do mountains get covered? Like, where does water always seeks what? The lowest place, right? So if the highest places are covered, everything else is too, in between, all right? The water was 15 cubits higher than the mountains which it covered, and the waters prevailed upon the earth 150 days, all right? So it doesn't just, this is the image we have, this calm little storm, a whole bunch of water fills up, and then it recedes, and that's it. All right, that's nothing near what a global flood would look like. All right, and notice the detail of the 15 cubits, by the way. Does anyone know how big the ark was supposed to be? How tall it was supposed to be? 30 cubits, right? So how much of a boat goes down into the water? Half of it. So if the water was 15 cubits above the highest mountain, are these people stupid scientifically? Like, here's how long ago was this written? And that detail is there. So if we can verify, okay, the water was 15 cubits above the highest mountain, that means that the boat's going to float clearly over everything, right? And it can actually come to rest on what was the highest mountain at the time, right? 5,000 feet above sea level. Which it covered, and the waters prevailed upon the earth 150 days. And God remembered Noah and all the living creatures and all the cattle which were with him in the ark, and brought a wind upon the earth, and the waters were abated. All right. The fountains also of the deep and the floodgates of heaven were shut up. All right, so whatever how the water came up from below begins to calm. And they began to be abated after 150 days. All right, what do you think water abating after 150 days, how fast do you think that water might move? That much water. Like, probably going to change the entire face of the earth, right? Everything that it comes in contact with is going to be different after the water flows through it. All right. And the ark rested on the 7th month, the 7th and the 20th day of the month, upon the mountains of Armenia. And you'll sometimes see that as Ararat, which was the high mountain. And the waters were going and decreasing until the 10th month. In the 10th month, the first day of the month, the tops of the mountains appeared. All right. All right. So this mountain is 5,000 feet above sea level. And if we do the math, we realize that they're in the ark for 371 days. So a year. The earth is underwater for a year before they can come out. All right, so, and here we just kind of summarize it very quickly. Noah enters the ark at day 0. So it's 40 days and 40 nights when the rain fell. And then over to the right, I have the various passages. And then 110 days, the water rises to its highest level and stays there. On 150th day, the springs of the great deep were shut off, and the rain from above ceased, and the water began to recede. And then another 74 days, the top of the mountains become visible on the 10th month and the first day. And then after 40 more days, Noah sends out the raven, and then 7 days later, the dove, and then 7 days later, another dove, which returns with an olive leaf. All right, and then 7 days more, and it doesn't return. So we're at 285 days. All right. And does anyone know like how why an olive? Like naturally, what is it about olive trees? They're unbelievably hardy, and they can literally grow off grafting off of like a limb of an olive tree, right? So this could have been a floating limb of an olive tree that suddenly grafted onto something into the ground and became a tree, all right? And then at last, hidden underneath our little thing here, let me move this, maybe. Noah removed the cover of the ark on the first day of the month. And then 2 months later, God commands him to leave the ark. All right, and that's 85 days. So 370 days of essentially a flood. All right. All right, so this global catastrophe, all right, that's article of faith. All right, now, what does science have to say about this global catastrophe? All right, let's see if we can, all right, and we're going to have, I keep putting this in the worst possible spot. All right. All right, so we're gonna look at five areas in which science supports the global flood, and the first is the testimony of the fossils themselves. All right. All right. So if there is this global catastrophe, then it's impossible that uniformitarianism is true. All right. Everyone sort of grasp at least conceptually why that would be, right? Because how many layers of sediment are going to be laid down by a flood, right, of that magnitude? Right? So it's either catastrophism or uniformitarianism. And if uniformitarianism isn't true, then evolution can't be either, okay, because it doesn't have the time that it needs, right? Because we know essentially when that flood was, right? So okay, if everything was wiped out, how did evolution recover after that, all right? And so you think about layers and layers of sediment, layers and layers of fossils, even maybe how they lay in the geologic column makes sense with a global flood, right? And it was all happened abruptly, not over millions of years. And then let's kind of look at these scientific observations. But first, we're going to return back to this, and I'm going to let the cat out of the bag as to how old that rock formation is. In that picture, that rock formation is 4 years old. 4 years old. It was created in 36 hours when Mount St. Helens erupted on May 18th, 1980. So Mount St. Helens is what is essentially called a living laboratory. And it proves that uniformitarianism is wrong, and this is why people don't like to talk about it, but it also destroys evolution because it destroys fossils and everything else. All right, so you may sort of know the story, right? So this catastrophic blast, there was about 24 megatons, right? You can see what it did to the mountain, right? This gigantic ton in Washington. And so it deposits about 8 meters, which is similar to about 25 feet of finely layered sediment all throughout that valley that it creates, all right? Which we saw the picture, right? So those fine layers don't take millions of years. It literally was done in 36 hours, all right? And then there's all this snow. There's a lake at the bottom called Spirit Lake, and there's all this snow inside the mountain, right? That obviously when it erupts, it boils and comes flying out, right? Waves of like 850 feet high, all right? Running through this valley, all right? And so that's how that got created, by the way, right? Do you see a river running? I don't have the picture, right? There's no river running through that down at the bottom, right? That canyon was made when the water rushed through, all right? From the, all right? So now we know exactly how long that is, okay? And I will tell you, I'll let you know that gorge is 140 feet wide and 150 feet deep, right? And it made it in 36 hours. 36 hours. Right? All right, so how do we then, knowing that, all right, knowing that that's a truth that we observed, hold on, let me see. Do we think the flood killed all the trees? Seems likely if water was on the earth that long, but then how did the dove get the olive branch or the other plants to survive? So in general, some of the hardier trees would have survived, even submerged. They weren't necessarily underwater so long that they would begin to fossilize, but some of the hardier trees, and certainly some of the plants, also the hardier ones, could have been transplanted on the land after. All right, so let's then first look at the fossil record and see if we can kind of decipher how it supports. So we've all heard about sort of the missing link, right? Like that's the problem that plagues evolution. All right, but the other part that they can't explain, which fits really well with the flood, is what they call the Cambrian explosion. All right, and here's what Richard Dawkins says about the Cambrian explosion. The Cambrian strata of rocks are the oldest ones in which we find most of the major invertebrate groups. And we find many of them already in an advanced state of evolution. The very first time they appear, all right, it is as though they were just planted there without any evolutionary history. Needless to say, this appearance of sudden planting has delighted creationists. Why would it delight creationists? So, because we already knew that they were there, right? They didn't just evolve to that point, right? And so what will always plague evolutionists is the lack of transitional species. They've never found a single one, right? And that's what they thought, like that, their whole theory hinges on transitional species, and they haven't found a single one. There's no transition pre-Cambrian from a horse to a zebra to a whatever. I don't even know how they necessarily would trace that, right? They don't find that, right? They don't find that, suddenly at the Precambrian, there's, this simple fish, and then, the Cambrian, then the fish is more advanced, right? They don't find anything like that, okay? But what it does do is, especially in the ways they find it, right, is that it kind of looks like that essentially took an environment that was fully populated with animals, and suddenly it was submerged in rock, right? And all these advanced forms, right? And also, most geologists would say, well, we think that the fossil record is complete, at least for the Precambrian, Cambrian, and Cambrian. Right? Most of them say, okay, there's 50 sites worldwide. They all look very similar as far as what we find in them. We think we have a really good feel for this, right? And so much so that there's sort of a movement now towards this thing called punctuated equilibrium. You guys ever heard of this? So rather than looking for a transitional species anymore, evolutionary biologists, I think Stephen Jay Gould was the first one to come up with this. He essentially says, well, there's this thing called punctuated equilibrium in which things just all of a sudden appear, right? Because that fits the data, right? And he says there's no transitional species. Darwin had that wrong. But without transitional species, why is punctuated equilibrium? There's no proof of punctuated equilibrium unless you're only willing to accept a naturalistic explanation, right? And so now we're into this sort of spontaneous generation as a scientific theory, right? Just suddenly the rhinoceros just pops into existence. But again, if you want to pull out God or creation out of it, this is your best explanation, right? Yes. Yeah. Well, but it's not a testable hypothesis, right? So in other words, it's a no lose situation for them. It's a theory. It's untestable. Just like we talked about, evolution in a lot of ways is untestable, right? And it doesn't really matter whether I mean, it's obviously that they have this sort of naturalistic fallacy, right? Like they're contradicting their own laws, right? Including like the idea that evolution actually means this unfolding of thing to thing to thing to thing, right? Not pop here, pop here, pop here. Like it's got to be continuous to be evolution. If it's not, that's something totally different. And that's really way beyond anything anyone has scientifically observed, right? Other than if you try to go and make sense of the fossil record by eliminating what historically we've understood to be the truth, right? So remember, the goal is throw out the flood, right? And you can see, and I know we talked about this, but I want to reiterate this point. You can see how important that believing the literal interpretation of the first 3 chapters of Genesis is really important, because now we just begin to start throwing out all the rest of the pieces, right? And that's what they're doing, systematically going through and saying, well, that's not really what happened. It's just a story, right? And how I was listening to a talk from a lady, this was a few weeks ago, and she just happened to mention, it wasn't even about the talk, but she was talking about how when she like rejected evolution, scripture came alive for her, because she no longer went into it and went, well, what do they really mean here? And it's, I mean, that experience, she put words through the experience of what this is for a lot of people when they go, wait a second, like, well, I don't have to take scripture and twist it around to make it fit evolution. Like I can actually look at science and show how it supports it. All right, so that's sort of where we're getting back, okay? So this idea then of punctuated equilibrium essentially throws out the link between microevolution and macroevolution, and just says, okay, there may be microevolution, but at some point, poof, a new species appears, okay? And so it's really hard to see a difference between that and special creation, right, in the end, other than the timing, right? So as, you know, as Catholics, we would say that as Catholics, we would say that God created in the first 6 days in the beginning. This punctuated equilibrium essentially says that something created out of nothing, you know, after the 7th day, sometime in recorded history. The other thing that I think remains hidden, which is really, if you try to Google how are fossils formed, have anyone ever done that? Good luck, all right? Because you won't get an answer, all right? And I'm sure it's out there, all right? But I want to make sure we sort of grasp how fossils are formed, because in essence, uniformitarianism makes it almost impossible for fossils to form if you really begin to accept it, all right? So a fossil, the definition, at least according to geology.com, are the remains, imprints, or traces of ancient organisms that have been preserved in the rock record. Bones, shells, casts, tracks, and excrement can all become fossils, all right? So the most important question is, well, how did the remains become preserved in the rock? Did, you know, an elephant just lay down one day, felt sick and died and just laid there, and eventually a little, you know, dust blew over him and blew a little more and a little more and a little more, and then, you know, a year later he was buried, and then it rained a little bit and he hardened in the rock? Like, is that really how a fossil would be formed? Because that makes it sort of seem, uniformitarianism would say, okay, everything that's going on now has to explain, right? And so those are just natural processes, right? But how is a fossil actually formed? Anyone know? Yeah. Yeah. So at death, the thing has to get buried really quickly, and it has to be buried in a certain kind of soil or a certain kind of sediment or something, so that there's a hardening around, so that microbes don't get in there and eat the. I mean, if you left an elephant outside, you know, in a field somewhere for 2 days, it would be completely scavenged, right? Gone. Right. So there's this idea then thinking, well, okay, a fossil is just something dead that is on the ground, but that's not what creates a fossil. A fossil is actually created when there's a catastrophe of some sort that buries it very quickly, right? And it doesn't have to be a global thing. It doesn't have to be but it has to be some sort of it has to be some sort of mechanism by which it's buried rapidly under some heavy sediment. Okay. And so it has to be able to harden quickly, so there's no bacteria in there to eat it. It has to exclude oxygen, so again, it has to be very quickly and usually underwater. So in other words, if you begin to think about, okay, well, we have all these fossils and all of them sitting in the Cambrian layer. Like, how did that happen so quickly? How did it happen so quickly? All right. And so it's a really reasonable thing to think, oh, wait, a global flood, right? What about the Ice Age? That's always the sort of the argument back, right? So how did the Ice Age form? All right. So in 1991, there was an eruption of Mount Pinatubo in the Philippines. And it was a gigantic volcano, right? And shot ash and chemicals and everything up in the air, right? And within a month and over the next year, global temperatures went down 1 degree that quickly, right? So now we begin to say, okay, with the fountains of the deep and all this tectonic and activity going on, you can imagine at the flood, what would happen to the global temperature? Get cold, right? And the fossil record, and we're going to talk about why that is in a second, but the fossil record, and we find all these frozen animals that were frozen obviously very quickly, right? They didn't just freeze to death. They were frozen and buried very quickly, right? So how did that happen? All right. Well, one, those breaking up of the fountains of the deep, right, that he's talking about in Genesis. So it's not enough just for the temperature to be cold, right? You need snow and ice. So can you get lots of snow and ice without a heating of the ocean temperatures? No, the answer is no, right? So we already eliminated the comet thing, right? Because the comet thing doesn't make snow and ice. It might make the temperature go down because it blocks the sun, but where do you get snow and ice from? The only way you get snow and ice is when ocean temperatures rise and they condense, right? And then once that happens, then there's snow and ice, right? All over the earth, right? And so that evaporated water is absolutely necessary for ice accumulation. Yes. So what happens to what evaporates in the air when the air temperature is colder? So think about so you're heating boiling water, right? And it condenses, goes up in the air, but the air temperature is really cold. And what's formed if you do that on a massive scale? Snow and ice, right? Right. So you have to have, so the ice age has to literally be, it's not just cold. You literally have to have ice and snow, right? And it has to do it so that these things are buried rapidly under ice and snow, right? So it's not just the temperature is cold. You really have to have a situation in which it's also snowing and you're getting ice, okay? And so when you actually look at the ice cores, like especially in the Arctic, right? There's all this evidence for the ocean being warmer at some point than they are today, right? Which would tend to support this idea, right? And then that totally makes sense. If we then, okay, so the ice age, the thing that is usually the obstacle is not necessarily an obstacle. It doesn't have to happen this way, right? But it fits the data and it still fits well within the context of the flood, right? Of the opening of the deep and the massive sort of volcanic activity. All right, what about the Cambrian explosion? All right, is there a way we can explain this? All right, so think about this for a second. So you have this geologic column, right, where things are buried, different strata, all these different strata, right? And you have this. So when things are buried in different places at more or less the same time, or at least buried in the same place, does time necessarily have to be the only explanation? Other than just simply saying, okay, one layer was clearly laid before the second one. Although there can be some simultaneous laying of layers, right? But as far as time, like, okay, it could be minutes, could be hours, could be years, but you have to interpret the geologic column as being in time, like big time differences between one layer and not. It's really important for us to grasp that, right? Because that's the assumption, right? The assumption to get us moving is always, okay, lower in the strata, millions of years before, all right? But what if the floodwaters come up with it and then recede back in the ocean, right? And as they're receding is really when they're laying the most sediment, right? What if the animals that took higher ground, because they're smart enough and big enough to know that, what if they're at the top of it, naturally? And what if the animals that don't get away as easily, they end up in the bottom? And what if the creatures that are really close to the ocean, they end up a little lower? And what about the ocean creatures and the plants? They might end up even lower. And so you see, you get this stacking, right? And that makes perfect sense of the Cambrian explosion because it explains why there's no transitional species. And we're not stuck with the timing, right? We're not stuck with reading it as if these were different times, right? Because we already have data from 40 years ago that says, oh no, these could be laid down really fast and really deep, right? And there's evidence for this too. Like in the Grand Canyon, for example, you find in these one layers, you'll find these footprints of amphibians at these lower levels. And then a few levels up, you'll find the fossils of them, right? Which would support, okay, it started running away and it got buried and it couldn't do anything about it, right? And so it appears that there's not this sudden there's not this smooth transition from one species to another, but it's all at once and discontinuous, right? There's also the problem of the fact that there are species that haven't evolved ever, right? Like you pick up if you were to find jellyfish, are a good example, right? They find jellyfish, right? And they're like, okay, this jellyfish is, 100 million years old. Well, why does it look like the jellyfish of today? Like, if evolution is moving, why are there so many of what you call evolutionary stasis, right? Where these things don't appear to evolve at all. Right? And they find thing after thing after thing after thing, right? And in fact, so many times they find this, it happened recently, I saw it, where there's this beaver they found and they named it something else. And then they looked at the beaver of today and they're like, oh wait, that's the same fossil, same skeleton. And there's millions and there's literally millions of examples of these. And so can evolution really say, okay, there's this bacteria, the cyanobacteria is another one, I think, it's supposed to be like 3.4 billion years old. And it's still here today, it looks exactly the same. You're gonna tell me that somehow that stayed as it was, but it's a foundational building block for life and it turned into something else, right? Those two things don't fit together, unless maybe it's not 3.4 billion years old, right? And so again, we're stuck with evolution in the gaps, right? When they can't show me what the next step was. The other thing too that sort of destroys this, there's two things. It's called the first is the polystrate strata, which you may have heard about this, or polystrate fossils. That fossil is actually of a tree, and the bottom of the tree, I think, is 10 million years older than the top of the tree. And that would tell me that actually it looks like that it was buried rapidly, standing straight up and down. And when we go to Spirit Lake in Washington, you know what they find? Literally thousands of trees that have fossilized in the bottom of that lake that look just like that. Right? And then the other, they have in the Grand Canyon, they have, it's really kind of cool. They have this graveyard. It's like 10,000 square miles of like all these just different creatures, right? It's just this fossil graveyard, right? Well, the reason a person would look at that and go, oh yeah, that's clearly like where something catastrophic happened and all these things died in one place. Right? It's the reasonable answer to that. And on the left, there's a lot of these actually. That is an ichthyosaurus giving birth to a baby, and in the midst of it got buried and died. Right in the midst of giving birth. And there's cool ones of fish doing the same thing, again, suggesting that it got rapidly buried, right? To the point of like it's in the middle of giving birth and never completes. And then there's land creatures and sea creatures all in the same fossil bed. There is an ammonite, which is a fish fossil in the Himalayas. Like, how did these get here, right? How did they get there when you're talking about them just piling one on top of the other, right? All right, so that's the testimony of the fossils. Other one, this is just a short one. We've all seen pictures like this, right? And so the explanation is supposedly that over time, slowly, the river fused its way through this valley and formed it, and then it continues to erode a little bit. But you think about it, if it actually started at the top as a river, would it look like that? Right? Because again, the forces are all the same, right? So the same amount of runoff should be happening every year, more or less. That's uniformitarianism. Or did a giant wave go through there? It's kind of what it looks like, right? If I were to put a giant wave running through a rock, and then you have all these overfit river valleys everywhere you go, right? It's a phenomenon. Every time you go into a valley that has a river in it, it's overfit, right? So the river is not, there's not enough water there to have made that. Right? And the water normally doesn't run that quickly anyway. But we should see the same thing, right? Because it should be happening time after time after time after time, right? So again, that looks like to me, the reasonable thing would be, okay, Genesis talks about a big giant flood. Oh, look, here's another data point that shows that actually happened. All right, so that's the overfit river valleys. Third, what about the rocks, the stones? All right, this is, I think this is in also, I think this is in the Alps. All right, can you see it well enough that you can see the shape of the strata, how they're curved, right? Have you ever tried to push up on rock so that it would curve? What will happen to the rock? Well, it'll break, right? Now, if you look closely, I mean, there are broken spots, but it wouldn't break, right? It wouldn't look, the strata wouldn't build like that unless when they were soft, something pushed up. So some kind of massive tectonic activity while they're still soft just pushes up, right? Again, we have something that looks like this in Mount St. Helens. So this geofolding is what it's called. Allegedly is supposed to happen with the slow continental drift of two plates bumping together, slowly pushing up, right? If you slowly push up rock that's hard, it breaks, right? So you'd see fractures, which you don't find, okay? So again, does that support a long period of time or that mount was made quickly? It supports it was made quickly, okay? Fossil stasis, which we already talked about. This is actually the jellyfish that I mentioned. I forgot I put the slide in here. And this is in Utah. It's supposedly 505 million years old of a jellyfish in Utah. I don't know when jellyfish were in Utah and why they were in Utah, but nevertheless, it hasn't changed in 500 million years, right? So 500 million years, at least according to, would be right in the middle of the Cambrian era, right? So that's where it's found. All right, so what about the coal deposit? Is another one. Anyone know how coal is made? Yeah. Yeah. All right, so vegetation, right, it's a fossil fuel. Vegetation gets buried, and it takes a long time for it to turn into, allegedly, a long time, all right? Although they've now mastered that they can do it with 150-degree temperature in about a month, all right? They can do this in a laboratory. And then if you want it to be really black coal, you just turn the temperature higher. All right. And so this group called RATE decided that they would look at the carbon-14 content of coal and diamonds. And the reason why they use at least diamonds, right, are the hardest substance. And so they're least likely to be contaminated from the environment around them, right? All right, so they looked at all of the carbon-14 content of the coal and diamonds, and they found that they were somewhere between 44,000 and 57,000 years old, based on several assumptions, and we'll talk about those assumptions in a minute. And then they even questioned one of the assumptions. But the point is that anything that has carbon-14 in it has to be less than 50,000 years old. All right, not because, well, we'll talk about that in a second why that is. But nevertheless, when they find coal deposits that still have carbon-14 in them, they can age them somewhere around 50,000 years old. And we'll talk about why that limit is there. The other thing is that, and we didn't talk about this with the sedimentary rock. So if we, all right, so think about a layer upon layer upon layer being laid, right? But that layer is exposed to the elements, right, for a certain amount of time before something's laid back on top of it. Right, so what would you expect to see in that layer? You'd expect to see erosion, right? They don't find that, right? They don't see it ever. It's smoothed out at all. It looks exactly like it was laid on top of each other and kind of filled in the gaps a little bit, and it's a little bit rough in between. And so if you had this like pointed, you know, in a layer that was on the surface, if it was pointed, it would eventually be roughed down, and you expect them to be really flat, right? So that, and again, you'd expect this on mountaintops too, right? You always see these big points on mountaintops. Like why, after millions of years, have they not flattened out, right? The same thing with the coal seams, right? So you would expect that if coal seams are millions of years old and they're being formed by, you know, this vegetation and this sort of building of it, right? You expect in the coal seams, you'd see erosion in between them, right? And they don't, right? So in other words, it was, however, it was made rapidly. It wasn't over time, all right? And so there's just this massive deposition of some plant matter into some water, and then it's buried, and that's why is there oil at the bottom of the ocean? Why would that place, you know, why is there, you know, why do they find coal in the places they find it, right? Near rivers and so forth, all right? So this massive amount of uprooted plants somehow buried in a very short amount of time, right? Or else you would see erosion again because they were exposed. All right, so I sort of hinted at this, and this is where we'll end with carbon dating. And I want to talk about radiometric dating just in general, and I'll try to keep it simple enough that I don't confuse myself. All right, so do you guys know about radiometric dating, right? So you have these sort of radioactive elements, right? Each of the elements has a half-life, right? Where over a certain period of time, it will decay to something else, and some radioactive element also will escape, all right? Be it alpha ray, get beta ray, whatever, all right, depending on the thing. Right, and you have things like potassium, for example. Potassium-40 has a half-life of, it's in the millions of years, I think, and it turns into argon-40. And I think the same thing with uranium and lead. And so all of these can be used because they learn what the half-life is in order to try to age something, okay? The problem, though, with using things like this as a clock is that you have to make certain assumptions, right? Because you don't really know what you're beginning with. And in fact, you don't really know you only know what you're ending with. So in other words, you have this clock and you know what time it is now, according to the clock, but you don't know when it actually started. Right? So you have this time where you're like, I don't know when it started, all right? And so in order for this to work, there has to be some assumptions, right? So we call the element that's undergoing the change the parent element, and then we call what it changes into the daughter element, okay? And so how accurate can this be if you have no idea how much parent element there was to begin with? Be really good if it was done in like this, you know, metaphorical vacuum, right? Because you would go, okay, that we used to have twice as, there was twice as much of this, and we know the half-life is this, so we could count back, right? But are there closed systems in which you can do that, where none of the parent element escapes other ways, none of the daughter element escapes other ways, and when it, and none of those two things leak back in either, right? And you could see that, when you're talking about millions of years, even the smallest little change, right? So you're like, oh yeah, there was, potassium started with this, and the half-life is, again, I don't remember what the half-life is. Let's say it's 100 million years, right? And we have this amount of argon now, and so that this must be, 150 million years old, right? But if it's off by just the smallest amount, when you're talking about numbers like that, right? Suddenly you're really off on the numbers, okay? And that's why that some of the ranges are huge, right? Even though they can measure pretty specifically how much is in there, right? The problem is they didn't know how much actually started with. And they assume that the rate is constant over time. So the half-life is the same throughout the whole life of the element, all right? Is that a reasonable assumption? We're going to talk about why it might not be in a second, all right? All right, so those three things, all right? So it's closed system, the rate is the same, and that there's no daughter elements to start with, and the parent elements themselves don't leak out and go other places, all right? And so you'll always see, what they'll try to do is they'll bracket the rocks, so they can use this to measure the age of rocks, right? And then they then imply that the fossils themselves are that age, all right? And typically what they do, they may try to do the same thing with the fossils themselves, and they'll take whatever is the oldest, all right? So again, it's like they're using a thing to prove the other thing, and neither one of them is known. So they have, they have three equations and two unknowns, essentially, right? Okay, so one of the better ways to do this is by using carbon-14. And the reason why this is particularly effective is because we have ways to calibrate it, right? So we know how old certain things are, and we can go back. So one of the ways they calibrated initially was they would use the remains of Egyptian pharaohs, right? And so they knew how long they'd been in the ground. They knew approximately when they reigned, and so they would calibrate their carbon-14 measurements by that. So let's look at the way carbon-14 is formed. All right, so carbon-14 has a half-life of 5,730 years. All right, and it's almost always applied to once living plants and animals, right? That's why they used it for coal, and why they use it in animals today. But remember what I said. First of all, it has a half-life of 5,730 years, so all of it is gone within 1 million years. All right, approximately. All right, and so the way they measure it isn't precise enough to go beyond 50,000 years. So if they detect any carbon-14 in something, it's no older than 50,000 years. All right. All right. So how does it work? All right. So carbon-14, the cosmic rays hit the Earth, and the gas is formed in cosmic rays are hitting the Earth. Molecules are formed, and then these free neutrons combine with nitrogen-14, and they become carbon-14, then fall to the Earth, combine with O2, and then turn into CO2. All right, that's in a nutshell. Okay, that's what all this picture is showing. All right. So once a creature dies, the carbon-14 essentially begins to decay back to nitrogen-14. All right, and so they know a living creature has a certain ratio of carbon-12 to carbon-14, and not to get into all of the details, but they can get pretty precise. All right. But it also requires, like all of these, that the amount of carbon-14 in the atmosphere has been constant. All right. Now, is that a reasonable assumption? Might not be, given the Industrial Revolution, for example. right, may have had an effect on it, right? Maybe they could adjust for that, right? But what if we went back to the flood and we realized that, oh, the atmosphere most certainly changed when that happened, right? Cosmic rays were not hitting the Earth the way they hit it now, right? And so the amount of carbon-14 in the atmosphere would have been far less than it is now, all right? And so this is why you'll see things like diamonds, that they'll age them at, in that example, right, was like 44,000 years or something, right? But this rate group has found a way to adjust back, and they're like, oh no, this is probably well under 10,000 years old. Right? And so now we're back in the time scale of the young Earth. All right. If we stop it there, if we stop it at when we think the flood was, and then we make adjustments for the fact that it wasn't constant from that point back, right? Which again is a reasonable assumption given the revelatory data we have, right? Because that everything changed with the flood. All right. So last thing. This is soft tissue that was found in a T-Rex bone in 2005 by an NC State professor named Mary Schweitzer. So what is the problem with finding soft tissue in a T-Rex? Should have been gone a long time ago, right? Just to be clear, right? This T-Rex lived sometime between 65.5 million and 145.5 million years ago. That's a long time, right? It's a long time for organic material to remain. Carbon-14 half-life, right, is, again, that we could still measure 50,000 years, right? A million years at the best. Right? And she finds all this soft tissue that's filled with it, right? And so this seems to suggest that the T-Rex was way younger than 65.5 million years ago, right? But thankfully, she said that because dinosaurs have iron-rich blood and just, seem to have been in a good environment for fossilization, that the soft tissue was able to remain for 65 million years at least, right? So you see, again, it has to be a natural explanation. It can't go to the biblical data. The reasonable thing to do is go, wait a second, we're way off on this aging thing. Because they're like, she just threw all science out the window at that point, right? There's no reason to think that iron-rich blood will last for 136 million years. 136 million years. Yes. I mean, there's no reason to like there were certainly dinosaurs around before the flood, and there may have been some after, right? I mean, there's no reason to think they weren't included in the, there is the exception of the, what does it say in Genesis? I think this is something like the creepy crawly things, whatever those are. He's like, leave those, right? But if there were, swimming dinosaurs, for example, like obviously Noah didn't put fish on his ark, right? And lots of fish probably survived, right? Just, bottom dwellers may have survived if they didn't get buried. So yeah, there's no reason to think that dinosaurs weren't on the ark, but something happened to them very quickly, and it's probably the Ice Age, right? And that's kind of consistent with what we see, that they just couldn't survive the Ice Age. All right. I'm pretty sure it was yeah, I don't know. The bone wasn't fossilized either, so you could probably, I mean, you could look it up. This is where I get out of my element very quickly. Like, you as the biologist would understand it way better than I would. But yeah, all right, so questions, and we can talk about some of the other